Welcome to Astronomy Daily, your source for the latest in space exploration and cosmic discoveries. I'm Anna.
And I'm Avery. We've got some fascinating stories to dive into today, from NASA's bold stance on the moon race to some incredible black hole physics that'll blow your mind.
Let's start with some big news from Capitol Hill. Acting NASA Administrator Sean Duffy is pushing back hard against claims that NASA is losing the moon race to China. During recent Senate testimony, there were suggestions that China might beat us back to the lunar surface.
And Duffy was having none of it. He responded with what I'd call confident determination. The timeline he laid out is pretty ambitious. Artemis 2 is scheduled for February 2026, which will be that lunar flyby mission with astronauts actually going around the moon for the first time since Apollo.
Then comes the big one, Artemis 3 in 2027, which would put American boots back on the lunar surface after more than 50 years. That's the mission everyone's really watching. Of course, there are always concerns about budget cuts affecting these ambitious timelines. But here's what's interesting. Duffy seems confident that Artemis will get full funding. More than that, he's really pushing for what he calls a culture shift at NASA, moving from endless analysis to actually taking action. It sounds like he wants to inject some of that old Apollo-era urgency back into the program.
You know, it really does feel like we're at this pivotal moment where space exploration is becoming competitive again, but on a global scale. The fact that we're even having conversations about a moon race in 2025 would have seemed like science fiction just a decade ago. Speaking of international competition, it's worth noting that China isn't just sitting idle either. Their Chang'e program has been remarkably successful, and they're planning their own crewed moon missions for the late 2020s. They've already achieved some impressive firsts, like landing on the far side of the moon with Chang'e 4.
But here's what I find hopeful. Despite all this talk of competition, there's still incredible cooperation happening. The International Space Station has been this amazing example of what we can achieve when we work together. Even during periods of political tension on Earth, astronauts and cosmonauts have continued working side by side in space.
And we can't forget about Europe's contributions either. The European Space Agency's James Webb Space Telescope partnership with NASA has been absolutely revolutionary. Plus, their Bepi Colombo mission to Mercury and the upcoming JUICE mission to Jupiter's moons show that some of the most ambitious science requires these international partnerships.
Absolutely. And speaking of science that seems like fiction, we have this incredible story about black holes that's just mind-bending. Scientists have measured the kick of a newborn black hole for the first time using gravitational waves. This is the stuff that makes me fall in love with physics all over again.
The technical term is black hole recoil, and this is the first complete measurement we've ever gotten. When two black holes merge and create a new one, the process isn't perfectly symmetrical. The gravitational waves get emitted more strongly in one direction, which gives the newly formed black hole a literal kick.
And when you say kick, you mean this thing is moving at 112,000 miles per hour. That's 150 times faster than the speed of sound on Earth. This baby black hole is moving so fast, it could actually escape from its home globular cluster entirely. Imagine that, a black hole getting literally kicked out of its own neighborhood.
The timing of this discovery is pretty remarkable too. It comes almost exactly 10 years after LIGO and Virgo first detected gravitational waves. Those detectors have opened up an entirely new way of studying the universe. We're literally listening to space-time itself ripple from these cosmic collisions. It's like having a completely new sense organ for astronomy. And this measurement opens up so many possibilities for studying black hole behavior that we never had before. We can start to understand not just how black holes form, but how they move through space after they're created.
What's really exciting is that this is just the beginning of gravitational wave astronomy. We're getting ready for even more sensitive detectors, like LISA, the Laser Interferometer Space Antenna. Unlike LIGO and Virgo, which are ground-based, LISA will be in space with arms millions of kilometers long.
That scale is just mind-boggling. LISA will be able to detect much lower frequency gravitational waves, which means we could potentially observe the merger of supermassive black holes at the centers of galaxies, or even primordial gravitational waves from the very early universe. We're talking about using Einstein's predictions to probe cosmic history going back to the Big Bang itself.
Now, shifting gears to astrobiology, we have some news from Saturn's moon Enceladus. That's a bit of a reality check for those of us hoping to find life in our solar system. New research is suggesting that those organic molecules in Enceladus's plumes might not be the biosignatures we hoped they were.
This is really important context. When Cassini discovered those water plumes shooting out from Enceladus's south pole, containing organic compounds from what we thought was the underground ocean, it was huge news. Everyone was thinking this could be where we find life in our solar system.
But these new lab experiments are showing us that those organic molecules might actually be forming on the surface due to radiation bombardment, rather than coming from the ocean below. Essentially, cosmic radiation hitting the icy surface could be creating these compounds through purely chemical processes.
Now, this doesn't rule out life entirely. That's important to emphasize. The underground ocean could still harbor life, but it does mean we can't just assume that detecting organic compounds automatically equals habitability. It's a good reminder that astrobiology is incredibly complex.
Exactly. And it means that future missions to Enceladus will need to be much more sophisticated. We'll need instruments that can distinguish between organic molecules that came from the ocean versus those produced by radiation on the surface. It's actually making the science more interesting, even if it's complicating our search for life. The good news is that Enceladus isn't our only hope for finding life in the outer solar system. Europa, Jupiter's ice-covered moon, remains incredibly promising. And then there's Titan with its lakes of liquid methane. Completely different chemistry, but potentially just as fascinating from a life perspective.
And we're actually going to get much better tools for studying these worlds soon. NASA's Europa Clipper launched last year and will start studying Jupiter's icy moon in detail. Plus, there's the Dragonfly mission to Titan that's scheduled for the 2030s, a nuclear-powered helicopter that will fly around Titan's surface exploring its prebiotic chemistry.
While we're talking about the search for life, we can't forget about Mars, where the search continues in real time. Percy, that's NASA's Perseverance rover, is still out there collecting samples that will eventually be returned to Earth by future missions. The Mars Sample Return mission is one of the most ambitious interplanetary projects ever attempted.
What I love about the Mars program is how it's evolved from just trying to reach the planet to doing incredibly sophisticated science. Perseverance is drilling into rocks that formed in what used to be a lake bed, looking for signs of ancient microbial life. And Ingenuity, that little helicopter, has far exceeded everyone's expectations. It was supposed to fly 5 times and has now completed over 100 flights.
You know, one thing that's really transforming space exploration is the rise of commercial partnerships. SpaceX has revolutionized how we think about launch costs with their reusable rockets. What used to cost hundreds of millions of dollars per launch is now dramatically more affordable, and that's opening up possibilities we couldn't even dream of a decade ago.
Exactly. And it's not just SpaceX. We've got companies like Rocket Lab launching smaller satellites more efficiently, and even newer players like Relativity Space trying to 3D print entire rockets. The democratization of space access means universities, small countries, and even private individuals can now fund space missions that would have been impossible before.
Speaking of the future, astronomy is about to get even more incredible with the next generation of space telescopes. The James Webb Space Telescope has already exceeded our wildest expectations, but there's so much more coming. The Nancy Grace Roman Space Telescope will give us panoramic views of the universe and help us understand dark energy and dark matter.
And don't forget about the incredible ground-based telescopes coming online. The extremely large telescope in Chile will have a mirror 39 meters across. That's bigger than a football field. Combined with adaptive optics to compensate for atmospheric distortion, it'll be able to image exoplanets directly and potentially even detect signs of life in their atmospheres.
It's incredible to think about how far we've come from those early days of space exploration to these modern marvels of technology. And that actually brings me to something that beautifully bridges past and future.
Speaking of making things more interesting, we have this wonderful story about restored NASA images that's bringing some real human emotion back to space exploration. Andy Saunders has spent thousands of hours restoring these deeply personal images from early space missions that were locked away in NASA vaults.
These aren't just any photos. We're talking about images from the Gemini and Mercury missions, including Ed White's first U.S. spacewalk and Buzz Aldrin's first space selfie. These missions were the crucial stepping stones that made Apollo possible. Without Gemini and Mercury, we never would have made it to the moon.
The fact that Saunders describes them as deeply personal really resonates with me. These weren't just technical documentation. They captured human beings taking their first tentative steps into the cosmos. Ed White floating in space, tethered to his Gemini capsule, was literally humanity's first taste of what it felt like to walk in space.
And now they're on exhibition at Jodrell Bank Observatory in Cheshire, which is just perfect. Jodrell Bank has been at the forefront of radio astronomy for decades. So having these restored images there creates this beautiful connection between different eras of space exploration.
It makes you wonder what other treasures are sitting in archives around the world waiting to be rediscovered and shared. The restoration process must have been incredibly painstaking. Thousands of hours of work to bring these moments back to life.
Before we wrap up, there's one quick item that caught our attention. The U.S. Air Force has selected Blue Origin and Anduril for something called the Regal program. Blue Origin got $1.3 million. Anduril got $1 million. The goal is to deliver cargo anywhere on Earth within 1 hour using rockets for military logistics.
That's fascinating from a technology perspective, using rocket technology for essentially very fast package delivery, but for military applications. It shows how space technology continues to find new applications back here on Earth. Though I have to admit, the idea of rocket-powered logistics sounds both exciting and slightly terrifying.
Whether it's GPS, satellite communications, or now rocket-powered logistics, space exploration keeps finding ways to benefit life on Earth.
That's exactly what makes this field so exciting to follow. Every discovery, every technological advance, every restored photograph connects us more deeply to both our cosmic heritage and our future among the stars.
Thanks for joining us on Astronomy Daily. Keep looking up, and we'll see you next time with more stories from the final frontier. In the meantime, you can get all the latest space news by visiting our website and checking out our continuously updating newsfeed. You can find us at astronomydaily.io.
Until next time, remember, we're all made of star stuff, and every day brings us new ways to understand our place in the universe.
And that's the beauty of this moment in space exploration. We're simultaneously reaching back to honor the pioneers who made it all possible, while stretching forward toward discoveries that will reshape our understanding of life, the universe, and our place within it.